Hi students, the next topic is the pipeline processing. So what is this pipeline? In a computing, a pipeline is nothing but it is a set of data processing element. It is nothing but a set of data processing elements which are connected in series, So here where the output of one element is the input of the next element. So it's nothing but as a set of data processing elements which are connected in series. The output of one instruction is the input of the next instruction. So this is the pipelining process. So before going to know about the pipelining process, let us how the program is executing in the form of pipelining. Let us see. So a program will be present in memory. So we have to fetch that program from memory. So whatever the data that is present in the memory, so whatever the instruction that we want to be execute, that will be fetched from memory. So here the program can executed in 5 phases. So whatever the instruction that is present in the program will be executed in 5 phases. So instruction get from memory and executed in 5 phases. So these phases are instruction fetch, instruction decode, opcode fetch, opcode execute, and operand store. Okay, so these are the different 5 phases that are take place when an instruction is executing in the processor. So first we have to fetch the instruction from memory. Fetch the instruction from memory. After fetching the instruction, you have to decode that instruction. So whatever the instruction that you fetch from memory, you have to decode that instruction. So after decoding the instruction, you have to fetch the operand. So whatever the operand that the instruction means the data is present, that operand you have to be fetched. After fetching the operand, you have to execute that operand. So after execution, finally we have to store the operand. Store operand. So these are the 5 phases that are taking place while a program or instruction is executing in the processor. So now coming to the pipelining. How this instruction is executing in the form of pipelining. In a program there are so many instructions. So one by one the instruction is executing in the processor. So each instruction will be executing in the form of pipelining. So before going to know about the pipelining process, let us see the difference between the pipelining and non-pipelining. So let us assume whatever the instruction that is fetched from memory will be executing in the form of non-pipelining process. Non-pipelining processing. So how the instruction is executing in the form of non-pipelining process. So first, instruction fetch, after that instruction decode, next operand fetch, operand execute, then operand stored. So one instruction is executed and stored in the memory. So this is a I instruction. So after the completion of the one cycle, it goes to the another instruction. Again it takes the another instruction from the program. It fetch that instruction from memory, instruction decode, operand fetch, operand execute, and finally operand stored. Okay. After that I+2. So likewise it is taking the instructions, each instruction from program and executing one by one. After the completion of one instruction, it taking the another instruction. After the completion of another instruction, it is taking the next instruction. So this is a non-pipelining process. So here the wastage of timing is more, because after the completion of one instruction only, you have to go to the another instruction. So see the pipelining process. So how the instruction is executing in the pipelining. Now coming to the pipeline processing. So how the instruction is executing with the help of pipeline processing. So in the first I instruction, first it fetch the instruction decode, operand fetch, operand execute, operand store. So in non-pipelining, after executing, storing the value of the first instruction, it takes the second instruction. But in the pipelining, so whenever one phase is completed, it takes another instruction. Means instruction fetch, instruction decode, operand fetch, operand execute, operand store. So this is the I+1 instruction. Next is the I+2. So I+2, instruction fetch, instruction decode, operand fetch, operand execute, next operand store. Okay, so this is the pipelining process. See the difference here. After completing of one instruction, only it takes another instruction. But in the pipelining process, only the phase is completed. So if the instruction fetch phase completed, then it takes another instruction. So in the phase of instruction decode, so whenever the first instruction is in the phase of instruction decode, it takes another instruction fetch. So in the case of operand fetch, suppose the first instruction is in the phase of operand fetch, and the second instruction is in the instruction decode fetch, and the third instruction is in the phase of instruction fetch. Here each phase will be different. So whatever the instruction you are taking from the memory, these phases are not coinciding with each other. So one is in operand fetch stage, and another is in instruction decode fetch, and another is in instruction fetch phase. So all are in different phases. So here the phase wise interleave is there. So whereas in this non-pipelining, this is instruction wise interleave. You call this as instruction wise interleave, and you call this as a phase wise interleave. So here you call this as a TP. TP is nothing but a phase duration. So phase duration. So this TP, each phase duration, means how much time it taking for each phase. And this is complete, you call it as TN. TN is nothing but is a total instruction duration. So this is the total instruction duration. So this is the way of pipelining processing. Means if you take any program from memory to have to execute that program will have different types of instructions. Each program will be divided into different instructions. So each instruction will be executed in 5 phases, different phases. So if you take in non-pipelining process, this is the way each instruction will be executing in the process. And the pipelining process, after the completion of one phase, it takes another instruction. After the completion of another phase, it takes another instruction. So here the total number of cycles will be, means the phase duration is 1, 2, 3, 4, 5, 6, 7. So here the phase duration is only the 7, whereas in here this is the 5, 5, 5, means 5 3 is 15. So here the phase duration is 15, and here this is only the 7. So the time wastage is also reduced in the pipelining process, and here the pipelining process will execute faster when comparing to the non-pipelining process. Okay, so here the pipelining is widely used in the modern processors. So it will be used in the modern processors. So and here it also improves the system performance. The pipelining processor will use it for system performance, increase the system performance we'll go for the pipelining process. So if the means the system performance will be increased in the form of throughput. Throughput is nothing but here's the number of works done at a given time. Okay, the main idea of pipelining in computer is the processor execute the program by fetching and executing the instructions one after the other. So let us see one example how this pipelining process will be executed. So let us take one example. So let us example will be the you want to execute one instruction AI star BI plus CI. So this is the instruction you have to be execute. This is a program that will be executed. So here the instructions will be for I is equal to 1, 2 up to 7. Let us assume up to 7. Means 7 instructions will be there. 7 cycles you have to be performed. Okay, here each sub operation is to be performed in a segment within a pipeline. Here each segment has 1 or 2 registers and that all will be connected in a combinational circuit. So let us take the sub operation of this instruction in each segment of a pipeline. Let us store R1. AI will be moved to R1 register and BI is moved to R2 register. So these are the inputs. So we are giving just inputs of AI and BI. So these are the inputs. And next R3 is doing the operation of R1 star R2. Means it is multiplying. So multiplying the both operands. So those operand values will be stored in the registers. So you have to do the operations only with the help of registers. First move the values into the registers and you have to do the operation only with the help of registers. You can't multiply direct operands or direct data. Okay. So R3, R1 star, R2. After that, so R4 you move the CI value. So whatever the CI value that will be moved to the R4. So R5 is, so A star BI means R3. R3 and CI is R4. So both have to be added. So the final result will be stored in the R5. Okay. So this is the example of the pipelining. So let us see how this will be written in the form of a diagram. So let us take this example A star BI plus CI. So this is the equation, that is AI star BI plus CI. So first we are moving the values into the registers. So AI will be moved to the R1 register and BI is moved to the R2 register. Okay. So what next? So we have to multiply AI and BI. So do multiplication. So you have to place the multiplier. After that multiplication, the value will be stored in the R3 register. Okay. So again you have to place the CI in R4 register. So now the R3 contains AI into BI and R4 contains the CI. So after that you have to add this value and this will be added. So place the adder. So that is R3 AI into BI plus CI. Final result will be stored in the R5 register. So this is the output. So this is the way how the instruction will be executed in the processor instruction by instruction. Okay. So let us see how the contents of these values will be stored in the form of a pipelining. So here the AI, BI and CI, we have taken the I from 0 to 7, 1 to 7. So this is the content of the registers in pipeline. So let us take the example of this, how here the instructions are executing in the form of pipeline. So this is the segment 1. The segment 1 is having the registers R1 and R2. R1 R2 is holding the values A, B, and segment R2 is R3, R4. R3 is doing the addition operation and multiplication operation, and the R4 is storing the value of C1, and the final result will be stored in the R5. So this is the segment 3. So it is doing the calculation of multiplier as well as means addition. It is doing the addition. Okay. So first clock pulse. During first clock pulse, the segment A1 and B1. So during second clock pulse, it is A2 and B2. And in the segment 2, it is performing A1 into B1, and this is the C1. So it is nothing is doing. So in the third clock pulse, A3, B3, it is doing the multiplication of this, and here it is adding A1 into B1 plus C1. Okay. So here one instruction is executed. So next again A3, B3. So this will be added A3, B3. A star, the segment 2 is doing the multiplication of A2, B2, and it's storing the value of C2, and the result will be here A2, B2 plus C2, which will be take place in the fourth clock pulse. So in the same way it is executing in the pipelining process. Means here you can check. Each phase will be different. So here it is fetching, and here it is decoding, and here it is executing. So each all the phases will be in different stages. No two phases will be colliding. So one instruction is executing in one phase, another instruction is executing in another phase. Okay. So this is like that, it is executing. Okay, and A6 here, and totally we have taken the 7, 0 to 7, A7, B7. So here the operands will be fetched. After fetching, it has to be decoded, and after decoding, it will be executed. So in one phase it is in one cycle it is fetching, in another cycle it is decoding, and in another cycle it is executing. Okay, so this is a example of the pipelining process. Thank you.